Hello geometry students, we are back for the part 2 section of lesson 11.6 and I have this new picture drawn for us. So it's all there. So why don't you pause the video right now and draw that picture, and remember that we are trying to find the area of the polygon. So what we've done so far is we found decided what we were going to do and found angle measures, which is the beginning of finding the area. And also we learned what an apothem was. And in this picture, it's right there. Okay, I'm darkening that. So why don't you go ahead and pause the video and we'll come back in a minute. Okay, so now we're going to move into finding the area of our shape and what the formula is. So we need a few things here. N is the number of sides. So we're going to be defining our variables. And the area of the whole thing will be N times the area of one triangle. So here I have in this picture, if I start here, I always mark it. I count 1, 2, 3, 4, 5. I have 6 sides. So I know I can make 6 triangles. So the number of sides tells me how many triangles I can make. And I'm going to multiply the area of one triangle times n. Now, what's the area of a triangle? Well, the area of a triangle is the formula 1/2 base times height. But we don't want to use that here because we're going to use the formula, but we're not going to call B the base or H the height. We're not going to use B and H. We're going to be using A and S. And you can see A and S here in our picture. So let's take this out and put in our other letters. So it would be 1/2, and I'm going to decide what it is by looking at the picture. So B would be the side, so that's S, times the height in here, which is A, my apothem. Okay, so this is a special case. We still use the formula that represents the base and the height, but we're using S and A to represent those instead of B and H. Okay, probably said that, but I hope that helps you. All right, now on the first video, we had our first example, which was number 1. So we're going to continue with example number 2 because we're in the same lesson. So let's write that down. If A equals 8 inches and S equals 10 inches, what is the area of the polygon? Assuming it's a 6-sided hexagon, like the one in the picture I already have. All right, well, all we do is put our numbers in. So I have my formula, N times 1/2 S times A. Now you could write that also as A times S, which they do in the book. They put it in alphabetical order. I just did it up here because B was S and H was A. Okay. So let's put that in. N is 6 sides, and then I have 1/2, and A is 8, and S is 10. So really, after you understand it, a lot of it is just about substituting numbers. And if I work that out, 8 times 10 is 80, half of that is 40, so 6 times 40. And then I get 240 inches squared. That would be the area of my whole hexagon. All right. Now, a subset of that would be, what is the perimeter? Okay. Well, the perimeter would be all the way around my shape, right? So if I have S, and I know S is the side length, and I know how many sides I have, I just have to multiply my number of sides times the side. And in this case, my number of sides is 6. The side length is 10. So it would be 60 inches, would be the distance around. Okay, let's do another example with the picture this time. You are decorating a tabletop with small tiles. What is its area? Okay, and if it looks like this, I have an octagon shape now. It's challenging to draw. And R is in the middle. And I know that it's regular, so all the sides are the same. And one side here is 15 inches. And I know that the radius here is 19.6 inches. And this is P and Q, and this is S. All right. So the question is, what is the area? So you're making a tabletop, and this would be a real problem. How would you figure out how to find the area? If you had cut out, you want to make a table, and you're cutting out an octagonal shape, which would be very cool. I'm sure you've seen tile tables like this with many little tiles on top. Or if you've gone to a museum, there'll be carvings with things etched inside. How many tiles would you buy? Well, you'd have to know the area of this shape. So let's work it out. Here's my formula. 1/2 A times N times S. Or you can write this as 1/2 times the apothem times the perimeter. You may do it either way. I like to think of it as finding the area of one triangle and multiplying by the number of triangles. But if you want to use the perimeter, that's fine too. Okay, so the first thing I'm going to do is find A, which is RS in the picture. All right. Now let's look at this. RS. I don't know it, but I do know that this side and every side is 15. So I know down here I can write that S is 15. I don't know my height. And I do know this radius. Now radiuses are all the same, so then I know this radius, RQ, is also 19.6. Well, look what I have in here. I'm going to change to a different color. I have a right triangle, is half of it, right here. Do you see that? So if this whole thing is 15, then half of it is 7.5. And look at that. I can use the Pythagorean theorem to find RS, or my apothem. Okay, so I'm going to use a squared plus b squared equals c squared to find RS. So I was not given just what SQ is. I was given the whole thing. So you have to step back and use those clues and go, okay, well, if I have the whole thing, which is 15, then I can use that to find my missing height there. So sometimes you have to do a little problem solving and hunting to see what clues you can use in the picture to solve it. Okay, so SQ is half of RS. So I take RS, and that's 15, so it becomes 7.5. And I don't know RS, so I'm just going to leave that, but I can put in my letters for the Pythagorean theorem. RS squared plus SQ squared equals RQ squared. And I still don't know this. And SQ would then be 7.5 squared. And RQ is 19.6 squared. All right. And if you use your calculator, you can find out what those are. So RS squared plus, and I'll just tell you, 7.5 squared is 56.25. And 19.6 squared is 384.16. Now I'm going to subtract. And I get RS squared equals 327.91. And the last step of that is to take the square root, and I get RS equals approximately 18. All right, so my first step was using the Pythagorean theorem. Let's go back and look at my picture. My apothem, to correct my picture, this is 18. So now I want to find the area of one triangle times the number of sides or triangles I have. So here's number 2. I'm going to find the area of the polygon. Step 2. And I have my formula. Apothem times number of sides times side length. Now again, the apothem is RS. So I'm going to use that. So I have 1/2, and I have 18, and the number of sides was 8, and each side length was 15. All right. So if I work that out, I get 9 times 120, and my final area is 1,080 inches squared. That is the area of my tabletop right here, the whole thing. Okay, so there were 2 steps. The first thing I had to do was find the apothem, and then I had all my other numbers. Now, what if that's not what you have? What if you have other information? Let's see what we can do with triangles and other tools at my disposal that I've learned all year. So this is number 4. A regular nonagon is inscribed in a circle with a radius of 4 units. Find the perimeter and area of the nonagon. Okay. Go ahead and write that down. Now, I'm going to try to draw this picture. It's not an easy one. So I have a circle. I hope your circle is better than mine. Goodness. Okay, I'm just going to, that's looking more like, I don't know, some weird fruit. So let's start over. Let's see, like this. And let's see how it goes. Try to make these about a third. And then a third. Whoops. Too big. So let's start over. I need 9. 1, 2, 3. 1, 2, 3. 1, 2, 3. Well, it's not great, but close enough. You can see my sides in here, right? Okay, so there's my picture of my shape, and it tells me it has a radius of 4, and this is L. So this length here is 4, and that means this length is also 4, okay? And I don't know anything else. That's all I know. But I know I'm going to make a triangle, and then I'm going to multiply it by the number of sides. By the way, a nonagon is 9 sides. So I know n is 9, just by the name. Okay, so I have this picture, and I'm going to draw in my height, and I need to find the height. I don't know this length here, and this is m. I don't know kj. I don't know lm. I'm going to need those. So I have a right triangle right here inside, and I have the hypotenuse. I don't know either of the other 2 sides. When I don't know 2 sides, then I have to use something else. If I have 2 sides, just like in the last problem, I could use the Pythagorean theorem. So I'm going to have to look at angles, and this is where finding the angles in part 1 will come in handy. So what I need here is LM, MK, and KJ. And to find those, I don't have enough side information, but I can use what I know about a circle. So my circle, there's the dog, someone's barking. Rosie's welcoming somebody inside. My circle, I know is 360 degrees. So I can find my angle measures here, and I can use those. Well, if I have an angle measure and one side, do you remember from this semester what we've used when we have an angle, a right triangle, and a side? We use trig. So we're going to use trig. Trigonometry comes in handy again. So let's start with our angles. The first one I need is the measure of angle KLJ. KLJ. Now I'm going to change colors. How about that color? So KLJ, right there. Now that's a central angle. And I know the whole circle is 360. And I know I have 9 sides. So if I divide it evenly by 9, I get 40 degrees. That's this entire angle right here. All right, now let's talk about another angle. I'm going to change colors again. Now I want to find the measure of angle KLM. Well, where's that? That's right here to here. This little angle, because remember, I have a right triangle in there. And if I know this angle, I can use trig. Well, because I have an isosceles triangle, my apothem bisects this angle. So I know that KLM is going to be half of KLJ. So it's half of the big one. The big angle, this little angle, is half of the big one. We went over this in number 1. All right. Now, once I know that this angle is 20 degrees, and I know this side is 4, my hypotenuse, I can use that with trig. All right? So I have this little angle here, and this is where I'm coming from, and here's my right triangle. Here's the whole thing. So what sides have I got? I have, sorry about that, my hypotenuse, and I'm looking from this angle. So I want to find MK. That's what I want to find first. So that's across. So I'm going to put the 20 in there so that you can see this. Okay, so that's my 20 degrees. And that's the reference that I come from, that angle. So I'm looking here and I've got opposite over hypotenuse. I want MK and I have the hypotenuse. So that is opposite over hypotenuse is sine. So I'm going to use my sine function. So I'm going to have sine of 20 degrees equals MK, which I want, over 4. Now I just solve for MK. So I use what I did in chapter 7. And I have 4 sine degrees equals MK. To get MK by itself, I multiply by 4. And if I take my calculator and I look up my sine function, so I'm going to put 20 in my calculator, and I hit sine, and I get 4 times 0.3420, and I multiply by that, and I get 1.36. Okay, so that's the first one. MK is 1.36, and let's go up here for just a second. That's this part right here. I'm darkening MK. It's this here. So now I can use the Pythagorean theorem because this is 1.36. I have 2 out of 3 of my sides. All right? So I can use my Pythagorean theorem to find LM. So let's write that down. This is one step. Use a squared plus b squared equals c squared to find LM, because now I have 2 sides of my right triangle. Okay, so one of them was MK. I'm going to put that in. Now LM, let's go up to the picture again real quick. LM is the side and 4 is the hypotenuse. So when I move down, I've got trying to find LM, and 4 is the hypotenuse. So when I square 1.36, I get 1.85. 4 squared is 16. I subtract 1.85 and I get m squared equals 14.16 approximately. Take the square root and LM equals 3.76. Now this is a lot of work. We are at the end of the year. This is one of our most advanced topics. Okay, so we're using a lot of things that we've used all year to get to this point. So now, let's go back up to the picture. I have my LM. I'm going to change colors again real quick. I have LM. I have MK. And I want to find the area of the entire triangle so that I can find the area all the way around of my shape. Okay, so let's use our formula. I'm going to go back down here. Area equals 1/2 A times N times S. So LM represents A. And that is 3.76. N is 9. Okay, now S. S is my side. All right, now when we were up here, we talked about how we needed 3 things. We got LM, we got MK. What else do I need? I need KJ. Why is that? Well, let's see. MK is only half the base. KJ is the full base all the way across. So I need to double this. This was KM, 1.36. So I have to double it. Let's do that. So S equals KJ, and KJ is 2 times KM, or MK, let's call it MK. So I get 2 times 1.36, and that is 2.73. So you just have to be careful with this. You have to make sure you have all your parts. And when I multiply that all together, I get 46.33 is it inches? Units. And that's the area of my non-gun. Okay, I'm going to give you a couple to do on your own. I know this is tough. This is challenging. You're going to have to really work hard and stay focused. And we're going to work together on this. So I'm going to give you some OIOs and I will go over them. All right? Let's change colors one more time. Here are your OIOs. Find the perimeter and area of each figure. Okay, here's number 1. It's just a picture and it looks like this. It's 5-sided, and they tell us that this is an 8. Now there's a circle here that we're not seeing. We'll just assume it's there. That represents the radius. And let me make this a little wider and bigger. My apothem is 6.5, and this is x and that is x. All right, I'll pause as soon as I have both of these written down. find the area of a pentagon with each side of 7 centimeters. Okay? So that's the only thing they tell you. You might want to draw a picture. A pentagon can be challenging. Okay, so why don't you go ahead and write those down and give those a shot, and I'll come back very soon. Okay, I'm back. Let's keep trying those problems. Area, I know you can do this. All right, the first thing we're going to do is write down the formula and figure out what we need and what's given. So the area is 1/2 the apothem times the number of sides times the side length. Okay, in this picture, I know A is 6.5. And I know also that N is the number of sides. Let me make that a nicer N. And let's see how many sides I have. 1, 2, 3, 4, 5. I've got 5. Okay, I know that. And S is my side length. And I don't know what that is. So right here, I don't know that. I don't know this here. So I need to find X. And inside here I have a triangle, right? Here's my little triangle. And let's see what we can do. So I need to find X. And in this case, I know the height, I know the hypotenuse. What I don't know is the side down here, but I do know 2 out of 3. So I'm going to use a squared plus b squared equals c squared. So let's figure it out. If a squared is the height, then I have 6.5 squared. This x I don't know, so that's b squared. And c squared would represent 8 squared. All right. So 6.5 squared is 42.25, and 8 squared is 64. Let's solve for x. And I get x squared equals 21.75. Okay, and to get x alone, I hope you've already tried this. X equals 4.66. All right, now back up here, remember, S is my side length and it goes all the way across. And half of it is X and the other half is X. So if I want S, S is going to be 2 X's. So that's going to be 2 times 4.66, what I just figured out. So S is 9.32.